of all, I'm going to start with the component of the neuromuscular-junction. We know this is the end terminal of the motor neuron. We know that this is the presynaptic component or element, or you can say membrane. This is the presynaptic element. This space in between here is known as the synaptic cleft, or you can say neuromuscular junction. This part here is the motor end plate, this plate, motor end plate, or you can say the postsynaptic membrane. Now, these are vesicles. These are acetylcholine neurotransmitters within the vesicles. Now, it is very important for us to know how these neurotransmitters are synthesized. It is also very important for us to know how these vesicles are synthesized. You can't just say, fine, this is a neuromuscular junction, these are the vesicles, these are the acetylcholine neurotransmitters. No, the vesicles come from where? They come from the cell body of the motor neuron. They are produced by the cell body of the motor neuron. The acetylcholine are produced when mitochondria, we should know that mitochondria too are found in this cell. The mitochondria provides acetyl-CoA. When they provide acetyl-CoA, I mentioned earlier the choline, acetylcholine, which has been broken down here and reuptaken here, back out here. This is a better diagram. I told you vesicles are produced by the cell body of the motor neuron. I told you that the synthesis of acetylcholine is when the mitochondria produces acetyl-CoA. Now, when they produce acetyl-CoA, the choline which has been taken from here through the choline reuptake channel reacts with the acetyl-CoA in the presence of an enzyme known as acetylcholine transferase. When that enzyme helps the catalyzation or the reaction between choline and acetylcholine is formed. And when it's formed, it is stored in the vesicles. Now, back to the sequence. The sequence is that vesicles containing acetylcholine are found in the synaptic membrane. When there's an action potential, the action potential stimulates voltage-gated calcium channels. These channels are depolarizing sensitive. They're sensitive to depolarization. So when there's a depolarization going through that action potential, the gates are open. And when the gates are open, there's an influx of calcium. Now what this calcium goes to do is that it goes to activate synaptic membrane found around on the vesicular membrane. Now the synaptic membrane is able to dock or fuse with the synaptocin found at the membrane, synaptic membrane. When it docks or fuses with the presynaptic membrane, the process known as exocytosis takes place. When the exocytosis takes place, the acetylcholine are introduced into the synaptic cleft. Now, when the acetylcholine are introduced to the synaptic cleft, they go and activate this receptor. I told you earlier, this receptor is a ligand receptor. That means it is stimulated or it is activated by a chemical. Now, when these receptors are activated, it is open. What happens? Sodium, there's an influx of sodium, and there's an influx of potassium going out. Now, this ionic or chemical difference in potassium and sodium generates what we call a local potential. This local potential is known as end plate potential, like I said earlier. But this local potential is not enough to, we can't call it an action potential. It is the end plate potential. If it can overcome the threshold potential of the muscle fiber, then it can now activate sodium-gated receptors at the muscle fiber. When it activates it, when it overcomes the threshold potential, it activates it, then there's an influx of sodium and potassium. This is enough to cause an action potential. Then I talked about this enzyme. This enzyme is acetylcholinesterase. It ends the whole process. This whole process. It ends it by breaking down acetylcholine into choline, which is taken back into the cell, and acetyl-CoA, which is taken into the bloodstream and into the liver. That's all about the sequence involved in neuromuscular transmission. The next question is the role of thymus in myasthenia gravis. At this point, I'd like to call on Mr. Danny to come out and give us.
thymus gland is one of the major glands of the immune system, as we have learned last lecture in histology. The thymus gland plays a role in Myasthenia gravis, as it is responsible for producing the antibody which interferes with the neuromuscular transmission. The function of the thymus gland is generate to mature T lymphocyte. In adults with Myasthenia gravis, their thymus gland is abnormal and contains nucleus of immune cells, which indicating lymphoid hyperplasia. Lymphoid hyperplasia is the rapid growth proliferation of normal cells that resemble with lymph tissue. So some individuals with Myasthenia gravis develop thymus mass or tumor of the thymus gland. So now if we talk about the idea of scientists, what scientists believe that, also scientists believe that the thymus may give indirect instruction to immune cells, which result in autoimmunity and then leads to Myasthenia gravis, ultimately resulting in autoimmunity in the production of acetylcholine receptors antibody, setting a stage for that neuromuscular transmission. So at this point, I would like to call on Dr. Ali to more shed light on the signs and symptoms.